Yasho Fede Ninjani. So we are done with the introductions, right? We have done the introduction to series, and then we said the series is simply what an addition of the terms that make up the sequence, right? And we did the sigma notation. Sharp. So now today we're going to be focusing on what the arithmetic series. Sharp. So to find the sum, or rather the sum of the first n terms of an arithmetic sequence, I'll show you two ways. The first one is the one that we did in the introduction, whereby we do what? We add the terms that make up the sequence. And then I'll show you the other method which will help us to derive an equation to determine the sum of the n terms of a series. Right? So let's get to it. So by looking at this sequence on the board, we have how many terms? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 terms, right? And since there is a constant difference between every successive term in the sequence, we can conclude that this sequence is arithmetic, right? Don't forget, in order for you to be dealing with an arithmetic series, you have to have what? An arithmetic sequence. Sharp. So you have to check your sequence whether it's arithmetic or not. So since this is an arithmetic sequence, like any other sequence, we can find the sum of the first n terms by just adding what? The terms that make up the sequence. So for the first one, let's find the sum of the first 3 terms of the series. So we'll have s sub 3. This will be 2 plus 6 plus 10. Right? So s sub 3 would be equals to 18. So the sum of the first 3 terms of a series is equals to 18. Let's find again the sum of the first 4 terms of a series. This would be 2 plus 6 plus 10 plus 14. Right? So therefore the sum of the first 4 terms of a series are, so this is 24, 30, 32. So it will be 32. Sharp. Let's find the sum of the first 5 terms of a series. So this again will be 2 plus 6 plus 10 plus 14 plus 18. Sharp. So 2 plus 6 plus 10 plus 14 gives me 32 plus 18. This will give me, so let me say 32 plus 18. Right? So S5, this is equals to 2. So 32 plus 10 is 42 plus 8, this is equals to 50. Sharp. So now, another way, if the series is an arithmetic series, we can use another method to find what the sum of the first n terms in a series, right? So we're going to do it this side using the very same numbers, right? So again, let's find the sum of the first 3 terms of a series. So what we do there, we write the series in the original order, and then we write it in the reverse order, and then we add the 2 series together, right? So this is what I mean. So we write the series as it is. It will be 2 plus 6 plus 10, and then we write the reverse of this series. So we have S3 equals 2. So the reverse would start with what? The last term until we end with the first term. So this would be 10 plus 6 plus 2. Right? And then we add the 2 series together. So it's going to be S sub 3 plus S sub 3. This would give us what? 2S sub 3. And then it's going to be 2 plus 10. So which means it's going to be the first term plus the first term. Remember, this is the last term, but in this case we reversed it, so it becomes the first term of the reversed series, right? So it's going to be 2 plus 10. This would give me 12. 6 plus 6, this gives me 12. 10 plus 2, again I get a what? A 12. So what we notice here is that when we do that, when we take the original series and the reverse of that series and we add them together, we will get a constant value that will be added. So in this case, we're looking for the sum of the first 3 terms. So which means the constant value that we find, we're expecting it to be added 3 times. So I can also write this as 2s sub 3 equals to 3 multiplied by 12, right? It's still the same thing. So calculator, 3 times 12, this gives me what? 36. So this is gonna be 2 multiplied by s sub 3 equals to 36. And then I divide this by 2. Therefore, the sum of the first 3 terms would be again what? 18. So this gives me back what? This value that I found using what? The method that we know how to find what's the first terms of a series. Let's look at the other example. We are looking at what now? Let's try to find the sum of the first 4 terms of a sequence using the very same method. Okay, so the first thing that we do, we write the original series or expression of a series, right? So this is going to be the sum of the first 4 terms. This will be 2 plus 6 plus 10 plus 14. And then we round up this sequence, or rather write it in a reverse order. So this would be S4 equals to, we start with the last term, we end with the first term. So this would be 14 plus 10 plus 6 plus 2. And then we add the 2 series together, so we have 2s sub 4 equals to 2 plus 14, I get a 16, plus 16 again, 10 plus 6, plus 10 plus 6 again, I get a 16, plus 16. So again, I get what? A constant value. Since we were looking for the sum of the first 4 terms, this constant value is added 4 times. So this can be represented as 2s sub 4 equals to 4 multiplied by 16. Again, calculator, 4 times 16, I get 64. So this will be 2s sub 4 equals to 64. We divide by 2, therefore the sum of the first 4 terms would be equals to 32. Again, I get the same value as before. Let's try the last one. Find the sum of the first 5 terms using this method again. Yeah, sure. Okay, again, so it's gonna be s sub 5 equals to the sum of the first 5 terms, 2 plus 6 plus 10 plus 14 plus 18. So this will be 2 plus 6 plus 10 plus 14 plus 18. 1, 2, 3, 4, 5, right? And then I write this expression in a reverse order. This will be s sub 5 equals to 18 plus 14 plus 10 plus 6 plus 2, right? So we have what? We have to add the 2 series together. So we have what? 2s sub 5 equals to 2 plus 18, we get a 20. Plus 6 plus 14, 20. 10 plus 10, 20, 20, 20, right? We were looking for the sum of the first 5 terms. Again, we're expecting this constant value that we find when we add the 2 series to be added 5 times, right? So again, this can be written as 2s sub 5 equals to 5 multiplied by 20. So 5 times 20, I get 100. So therefore, 2s sub 5 would be 100. Divide this by 2, therefore s sub 5 would be 50. Sharp. So I hope by doing this, guys, you get what the pattern that I'm trying to show you. So whenever we are dealing with an arithmetic series, right, we can write the expression of the series and then write the reverse of that expression and then add the 2 series together. Then we should get a constant value that is added up. So if we're looking for the sum of the first 3 terms, that constant value has to be added 3 times. If we were looking for the sum of the first 4 terms, that constant value has to be added 4 times, right? So what we're going to do from now on, we're going to use that very same idea to help us find what the sum, or rather the equation of the sum of the first n terms of an arithmetic sequence. Sharp. So let's go do that right now. Yeah, sure. So before we can find the equation for the sum of the first n term of an arithmetic sequence. Let's first consider this situation. So let's say we are given a sequence where we are given the first three terms of the sequence and the last term of the sequence, and we are asked to find what the sum of this of the series from the sequence. So we will do what we did before. So we find the series, or rather the expression of the series from this sequence, and then we write it in reverse, and then we add the two series together, right? But now the problem here is that we have three terms here, and then we have one term in the last terms, right? So we have to find the two terms previous to the last term. So since we know that this is an arithmetic sequence and it has a common difference of 4, we know to get to the next term we add 4. So therefore, to get to the previous term we have to subtract 4, right? So to move from the last term to the previous term, we have to subtract what? 4. So this would be 42 minus 4. This would give me what? 38. And then from there, to get the previous term from 38, it should be 38 minus 4. This would give me 34, right? So now we have what? The first three terms of the sequence and the last three terms of the sequence. So we can write this in a series form. So we have what? Sn. Because we do not know how many terms we are summing up, so we write it as n. So this would be 2 plus 6 plus 10 plus all the way to the last three terms of the series. So this would be 34 plus 38 plus 42. So what's left now is to write the reverse of this series. So this would be S sub n equals to 42 plus 38 plus 34 plus all the way to the last three terms. So this would be 10 plus 6 plus 2, and then we add them together. So we would have 2s sub n equals to 2 plus 42, this would be 44, plus 6 plus 38, this would be 44, plus 10 plus 34, 44, plus all the way to the last three terms. 34 plus 10 again, we get what? 44, plus 38 plus 10, we get what? 44 plus 44. Sharp. Again, we see that by adding the two series, we get what? A constant value that is added up. But in this case, we do not know how many times we are adding it up. So that is why we write n, right? So in this case, it will be 2sn equals to n times. So we are saying that 44 is added n times because we do not know how many times it's being added. So therefore, Sn would be equals to n over 2 multiplied by 44. How can we find the n value, right? Again, don't forget, we know that this is an arithmetic sequence. So we go to the general term of what? Of the arithmetic sequence. So it's t sub n plus a plus n minus 1 multiplied by the common difference d. Sharp. We know that the last term that was summed up was 42. So we know that our Tn should be equals to 42. We have our first value as 2, so we have A equals to 2. We have already found our difference, so D is equals to 4. So we can solve for what? For n. So this would be 42 equals to, what's our A value? 2 plus n minus 1 multiplied by 4. So this is 42 equals to 2 plus 4n minus 4. So 42 equals to minus 2 plus 4n. Transpose, and then we'd have 44 equals to 4n. Therefore, n should be equals to, starting my chance, 44 divided by 4, this would give me what? 11. So which means n is 11. We are adding up how many terms? 11 terms. So we take this 11 and substitute it where there is n. So it will be S11, or the sum of the first 11 terms, equals to 11 over 2 multiplied by 44, right? So therefore, S11 would be 11 over 2 multiplied by 44. This would give me what? 242. This is how you would solve this if you do not if you do not know how many terms you were supposed to be adding up, right? You have to have the first 3 terms of the sequence and then have the last 3 terms of the sequence and then write them in a series order, and then write that series in reverse order like we did before, and then you would calculate it up. So since we don't know how many terms we are adding up, it's going to be n. So this 44 will be repeated n times, and then we can find the value of n like this, sharp. So now let's find what the equation for the sum of the first n terms of an arithmetic sequence. Yeah, sure. Now that we have seen how an arithmetic series can be summed up, let's use that idea to find the sum of the first n terms of an arithmetic series, right? Remember, you can find the sum of an arithmetic series by just taking the terms that make up the sequence and adding them up, or from those terms that make up the sequence, you can create 2 series, right? You write the first order and then you take that order and you write it in reverse, and then you take the 2, you add them up, right? So now what I've done here is to find what the expressions of the terms that make up an arithmetic sequence, sharp. So what we can do from this is do what is create our series. So we'll have what Sn should be equals to the first term. The first term is a plus the second term. The second term is a plus d plus the third term. The third term is a plus 2d, right? We add this up all the way to the last 3 terms. So this would be a plus n minus 3 multiplied by d plus a plus n minus 2 multiplied by d plus the last term a plus n minus 1 multiplied by d. Now we have to write this series in reverse order, starting with the last term and ending with the first term. So this would be Sn or S sub n equals to the last term. So this would be a plus n minus 1 multiplied by the common difference d plus a plus n minus 2 multiplied by d plus a plus n minus 3 multiplied by d plus all the way to the first 3 terms of the sequence, or rather the series, starting with this term. So this will be a plus 2d plus a plus d plus a, right? And then from here we know that we have to add the 2 series together. So we have what? S sub n plus S sub n would give us what? 2s sub n, right? So this would be equals to, so again we add the first terms of the 2 series. So it will be a plus, so this is a plus this one, so this will be a plus n minus 1 d, sharp. So in this case the only like terms we have is just a, so this would be 2a plus n minus 1 multiplied by d. So this will be our first expression. So we'll have 2a plus n minus 1 multiplied by d plus, we add what? The second terms of the 2 series. So this is a plus d plus this one. So this will be a plus n minus 2 multiplied by d, right? So we can collect the like terms here. So we have a plus d. Then this one I can distribute, so it will be minus 2d plus nd. So a plus a again, I get what? 2a, right? D minus 2d, this would give me what? Minus d plus nd. So I would have 2a plus minus 1 plus n multiplied by d. Therefore this is 2a plus n minus 1d. So I get the same expression. So this would be 2a plus n minus 1 multiplied by d, sharp. So let's do the last one, because if the last one gives us what, the same expression, we're expecting the last three to give us what, the very same expression. Or you can do it yourself. Sharp. So we add what now? The third terms of the series. So we have a plus 2d plus this one, a plus n minus 3 multiplied by d. Sharp. So we collect the like terms again. We'd have a plus 2d, distribute the d inside the bracket. We have negative 3d plus nd. A plus a, we get 2a, 2d minus 3d, we get a negative d plus nd, right? So we have 2a plus minus d plus nd. Therefore, 2a should be equals to, 2a plus n minus 1 multiplied by d. So again, we get the very same expression. So this is plus 2a plus n minus 1 multiplied by d. So if we continue this up to the last term, we would find that we have the same expression. So if we repeat this n times, so this would be 2a plus n minus 1 multiplied by d. Sharp. So let's erase this. So now we know that we are adding this n times, right? So which means this expression is going to repeat itself n times. So we can write this as 2s sub n equals to n multiplied by 2a plus n minus 1 multiplied by d. Sharp. And then the sum of the first n term of an arithmetic sequence can be n over 2 multiplied by 2a plus n minus 1 multiplied by d. So this is the expression that represents the sum of the n terms of an arithmetic sequence. Or rather, this is the first one, right? So in this case, if you are given 3 terms of an arithmetic sequence, you can find your a value, you can find the difference, and then you can find the sum if you are given how many terms you should add up, right? Another way, I can open up this 2 into a plus a, right? So I can have Sn equals to n over 2. 2a, I can write it as what? A plus a. And then plus n minus 1 multiplied by d. And then if we look at this, this gives us what? The general term of the arithmetic sequence, or rather the last term of an arithmetic sequence. So it can be written as Sn equals to n over 2 multiplied by a plus Tn. Or you can write it like this: Sn is equals to n over 2 multiplied by a plus L. So this L represents what? The last term. Sharp. So this one you can use if you are given what? The first term of the sequence and the last term of the sequence. This would help you to find what? The sum of the first n terms of the arithmetic sequence. So we know from the, how to find n. If you are given the last term of the sequence, you can find n by using what? The general equation of an arithmetic sequence. Sharp. So from here we can go and look for questions and see how we can apply this. Yeah, sure. So now we have derived what? The 2 equations that represents what? The sum of the first n term of an arithmetic sequence. So now let's see how we can use them in a question. So let's look at this 3 questions. They say here that we should calculate the sum of the following arithmetic series. So we'll start with this one. So here we are given what? The first term and the last term, right? So we can use what? The second equation, which is Sn equals to n over 2 multiplied by the first term plus what? The last term, right? Here your first term is 53 and your last term is 80. So the last thing that we need to do is to find what? The value of n, right? Remember, how do we find the value of n? We know that this is an arithmetic series, therefore it's from an arithmetic sequence. So we can use the general term Tn equals to a plus n minus 1 multiplied by d. Sharp. Still here we have what? The a value being 53. The common difference here it's going to be 56 minus 53. So we have the common difference as what? As, so our common difference is 3. Sharp. So we can solve for what? For the value of n. Oh, again, the Tn term is equals to 80, which is the last term of the series. So we substitute. So we have 80 equals to a 53 plus n minus 1 multiplied by 3. So this is 80 minus 53 equals to 3n minus 3, right? So we have 80 minus 53 plus 3 equals to 3n. So this is 80 minus 50, right? So this is equals to 3n. So we will have 30 equals to 3n. So n would be equals to 30 divided by 3. So therefore n is equals to 10, right? So which means we are summing up what? The first 10 terms of the series. So we have S10 equals to 10 over 2 multiplied by a 53 plus the last term 80. So therefore the sum of the first 10 terms of this series is equals to, put it to calculator. So we'll have 10 over 2 53 plus 80. So this would give me 665. So we'd have 665. So this is the sum of what? The first 10 terms of the series. Sharp. So let's look at number 2. Raise here. So for number 2, they say that find the sum of the first 12 terms of the arithmetic series given by 2 plus 5 plus 8. So here we do not have what? The last term of the series, right? So we can use which equation? The first one, which is Sn equals to n over 2 multiplied by 2a plus n minus 1 multiplied by d. Sharp. So we are given n because we are told that we should calculate the sum of the first 12 terms of the series. So we know that our n value in this case is equals to 12, right? Again, we are given the 3 terms that are being summed up, so we know the first value is 12. So therefore a is equals to 2, right? So the only thing that we need to find is what is the common difference. Again, it's the second term minus the first term, so it's going to be 5 minus 2. Again, we get the common difference of what? Of 3. Then we can take this, substitute into this equation. So we have S sub 12 equals to 12 divided by 2 multiplied by 2a 2 plus, what's the n value? 12 minus 1 multiplied by 3. Sharp. So we have S12 equals to 6 4 plus 11 multiplied by 3. So this is equals to 6 4 plus 33 equals to 637, right? Therefore S12 is equals to, so this will be 6 multiplied by 37, so 6 multiplied by 37, I get 222. So this will be 222. So this is the sum of the first 12 terms of the given series. Sharp. And then we go and use what? The sigma notation. So now we are given what? The sigma notation. So this follows from this question. Calculate the sum of the following arithmetic series. So the first thing here that we need to do is to do what? Is to formulate a series for ourselves so that we know the terms that were added. So this is equals to, remember that we sum up the expression to the right of the sigma notation from the lower bound to the upper bound, right? So I'll write the first 3 terms and the last term. So what we have here, it will be 4 minus 1 plus 4 minus 2 plus 4 minus 3 plus all the way to the 30th term. Let me write it here. Plus all the way to the 30th term. So that will be 4 minus 30. So this is equals to 4 minus 1, we have 3 plus 2 plus 1 plus all the way to the last term. So our last term is 4 minus 30. That's 20, a negative 26. So we have this as negative 26, right? So we have our first term and our last term, and our n value in this case is given as what? As 30. So we can use what? The second equation. So this would be Sn equals to n over 2, right? Multiplied by the first value plus the last term. So it will be S30 equals to 30 divided by 2 multiplied by the first term, which is 3, plus the last term, which is minus 26. So S30 is equals to 15 multiplied by negative 23, right? So therefore S sub 30, or the sum of the first 30 terms of this series, is 15 multiplied by negative 23. We get negative 345. So this is how we can use this equations that we just derived to find the sum of the first n terms of what? Of an arithmetic series. So what I can do here is find more questions, but I don't think I can be able to do it because it paid relatively low, right? We will do more intense questions as we do our question papers. So what I will do here, like we did on the previous videos, I'll send the questions for you. You will practice on your own, and then I'll send solutions. Sharp. So I have decided that I'm no longer going to send them a question at the end of the video. So what I'm going to do is do the last 3 questions with you, and then that will be it with the video. So let's look at the first question of the 3. So here they say, how many terms of the arithmetic sequence 34, 40, 46 will sum to 1530, right? So which means they have summed up the first n terms of this given sequence to get what? This value. So we have what here? Sn is equals to 1530, right? So we want to find out how many terms were summed up in order to get what? This value. So we're going to solve for what? We need to solve for n. What you need to notice is that this is not the last term of what? Of the sequence. They did not say this is Tn is equals to 1532, right? So we can't use what? The general term of an arithmetic sequence to solve for n. So we can't use this. But we can use what? The 2 equations that represent what? The sum of the first n term of an arithmetic series. So those are what? Sn is equals to n over 2 multiplied by 2a plus n minus 1 multiplied by d. Or we can use this one. Sn equals to n over 2 multiplied by a plus the last term. Sharp. But now, for this one you can't use because we are not given what? The last term of the series, or rather the sequence. So the only one that's left that we can use is this one. So let's remove the equations that we do not need. So here what we need to find is the a value and the common difference d. By looking at the sequence, we can tell that a is equals to 34. And then to find the common difference, we'd say 40 minus 34. This gives us what? 6. 46 minus 40, this gives us 6. So therefore, the common difference of the sequence is equals to 6, right? And then we substitute in the equation. So we have 1530 equals to n over 2 multiplied by 2 multiplied by 34. This is the a value, plus n minus 1 multiplied by the common difference, of which is 6. And then I cross multiply. This would be 2 multiplied by 1530 equals to n. Multiply by 2 times 34, this would be 68, plus 6n minus 6. So 2 times 1000. So for this one, I'll have 2 multiplied by 1530. This would give me 3060. So this would be 3060 equals to, then I distribute the n, or rather let me first solve what is inside the bracket. So this will be n multiplied by 6n plus 68 minus 6. So this will be 3060 equals to n multiplied by 6n, 68 minus 6 plus 62, right? Then I can distribute the n inside the bracket. So this will be 3060 equals to 6n squared plus 62n. Then I will transpose this value to the other side. So I would have 6n squared plus 62n minus 3060 equals to 0, right? So to solve for the values of n here, we can use what, the quadratic equation, because this is a standard form of a quadratic, right? So we will have n equals to minus b plus minus b squared minus 4ac all over 2a, right? Then we substitute. This is n equals to minus, what's the b value? 62, plus minus b 62 squared minus 4, the a value is 6 multiplied by negative 3060 all over 2 multiplied by a, which is 6. Therefore n should be equals to 2 values. So let's put this into the calculator. So we have negative 62 plus square root of 62 squared minus 4 multiplied by 6 multiplied by negative 3060 divided by 2 multiplied by 6. This will give me n is equals to 18. Let's find the other value. So this would be negative, we have negative 85 over 3, right? But now, since this is a negative value and also it is a fraction, this can't be the n term, because the n term always has to be what, a positive integer. So this is not the n value. The n value that we're looking for is what is n is equals to 18. So therefore we conclude that the sum of the first 18 terms is the one that is equals to what, 1530. So we have to add 18 terms of the sequence in order to get what, the this value. Sharp. So let's go and look at what the second question of the 3 questions. So this is the second question of the 3 questions. So it says the sum of the first 5 terms of a finite series is 40. The fifth and last term is 14. Determine the first term and the common difference, right? So what are we given here? We are given what, the sum of the first 5 terms. So we are given s sub 5 as what? As 40. And then we are given what, the fifth and the last term. So they are telling us that the last term is what, is t5. This is equals to what, 14. Sharp. And then from here we should determine what, the first term and the common difference. So since we are given the first term, we can use, the last term, we can use Sn equals to n over 2 multiplied by a plus the last term. So since we have s sub 5 and t sub 5, we know that our n should be equals to 5. So we have the last term, we have the n value, we have the Sn value. So therefore we can solve for what? For A. And remember, when we find our A value, we have already found what? The first term of the arithmetic series. So this would be, substituting here, we have S sub 5, this is equals to 5 over 2 multiplied by A plus the last term, which is 14. S sub 5 is equals to 40, equals to 5 over 2 multiplied by A plus 14. Cross multiply, and then I'll have 2 multiplied by 40 equals to 5 multiplied by A plus 14. Because I want to make A the subject of the formula, I will divide by 5, then transpose the 14. So I'll have 2 multiplied by 40 divide by 5. This is equals to A plus 14. And then from here I divide the 14, transpose the 14. So we would have 2 multiplied by 40 divide by 5 minus 14. This is equals to A. So what's left here is for us to put this into what? Into the calculator. So we have 2 multiplied by 40 divide by 5 minus 14. So therefore this gives us 2. This means that the value of A is equals to 2. So since the value of A is equals to 2, we conclude that also the first term is equals to 2. So we have already solved for what? For this part of the question. So now we have to find what the common difference of the series, or rather the sequence. We have what? We have that the last term of which is T5 is equals to 14. We have the value of n, and then we have the value of A. Therefore we can solve for what? Our common difference, using what? The general term of the arithmetic sequence. So this is Tn A plus n minus 1 multiplied by D. So we have T sub 5 equals to, what's our A value? 2, plus 5 minus 1 multiplied by what? By our D. But our T sub 5, or the fifth term of the sequence, is equals to 14. So this will be 14 equals to 2 plus 4, 5 minus 1, 4 multiplied by D. And then I transpose the 2, then I would have what? 14 minus 2. This is equals to 4D. And then divide everything by, let's just say 12 equals to 4D. Then divide by 4, divide by 4. Therefore, D is equals to what? 4A12. D is equals to 3. So therefore, we have solved for the second part of the question. This will be the last question, and then we'll be child with the video. So let's look at the question. So the question says the first 3 terms of a finite arithmetic series are negative 20, negative 15, and negative 10. If the sum of, they should be off here, if the sum of this series is negative 35, how many terms are in the series, right? So we are given the sum of the series as what? As negative 35. So we are given what? Sn is equals to negative 35, right? So they're saying how many terms are in the series. Just like the first question, we are supposed to solve for what? For n. So since we are given the sum of the first n terms, we are going to use what? This equation. Sn is equals to n over 2 multiplied by 2a plus n minus 1 multiplied by d. We can't use the other question because we do not know what the last term of the series is. So here we have what? We have Sn is negative 35, right? We know that we are supposed to solve for n. And also we are given 3 terms of the series, or rather the sequence. So we have the A value. Our A value is negative 20, and then our common difference, this would be T2 minus T1 should be equals to T3 minus T2. So we have minus 15 minus, this is plus 20, this is equals to minus 10 minus 15, this is plus 15. So we have 5. So therefore, our common difference is equals to 5. So we have A, we have D, we have S sub n. So we can substitute and solve for what? For n. So this is negative 35 equals to n over 2 multiplied by 2 multiplied by the A value, which is negative 20, plus n minus 1 multiplied by the common difference, which is 5. And then I'll cross multiply here, would have 2 multiplied by negative 35 equals to n. This is multiplied by negative 40 plus 5n minus 5. Sharp. So this is negative 70 equals to n. So this would be 5n minus 40 minus 5. So negative 70 is equals to n 5n minus 45. Then I distribute the n inside the bracket. So this would be negative 70 equals to 5n squared minus 45n. And then I take this negative 70, I transpose to the other side. So we have what? 5n squared minus 45n plus 70. This is equals to 0. Sharp. We can use again what? The quadratic equation. But in this case, I see that we can find the factors of what? Of this equation. So I'll divide by 5 all throughout. So I'll have what? N squared minus 45 divided by 5. 45 divided by 5 minus 9n plus 70 divided by 5 plus 14. This is equals to 0. So what we have to do is find what? The factors of this equation. So this would be n. So I'm looking for numbers such that when I multiply they give me what? 14, or when I add or subtract they give me 9. So that would be 7 and 2. So which means 7 and 2, right? But I have to, when I multiply them, they have to give me positive 14. And when I add them, they have to give me negative 9. So in this case, it has to be negative, negative. Because negative 7 times negative 2 gives me what? Positive 14. And again, negative 7 minus 2 gives me what? Negative 9. So which means this our factors are negative 7 and negative 2. Sharp. So therefore, n should be equals to 7, or n is equals to 2. Sharp. So now, because the two values are both positive integers, we are saying that the sum of the first two terms will be equals to negative 35, and also the sum of the first 7 terms will also give us what? Negative 35. So to be sure we can check this. You can check this on your own, because substituting all of this into the equation will take time, right? When you find time, of which if you pick the video you have time, you can check for yourself. The sum of the first 7 terms will be negative, the first 2 terms will be negative 35. Also the sum of the first 7 terms will be negative 35, right? Sharp.